All right, next lesson in geometry. I can use congruent triangles. This is the CPCTC theorem postulate. And so what this means is corresponding parts of congruent triangles are congruent. So I want you to pause and say that at least 4 or 5 times. Corresponding parts of congruent triangles are congruent. So what this means is that if you can prove that a triangle is congruent, then all parts of that triangle are congruent. The sides, the angles, anything that you want to prove, if you can get it to be congruent, you can then prove anything. So first identify the congruent triangles and give the reasons. Remember, the order that we state these matter. So I might say that, again, what do I look for? I look for shared angles, shared sides. So let's see here. Statement and reason. I'm going to say that BC is congruent to BC due to the reflexive property. And so I now know that this is congruent here. So I could say that triangle ACB is congruent to triangle DCB by the side theorem. And then because I've now proven that it's congruent, I could say anything, which again, what is the question asking me? Always keep that in mind. What's the question asking me? The question is asking me to prove that congruent A is congruent to angle D by CPCTC. Prove side JM is congruent to side LM. So I'm trying to prove that this side is congruent to this side. Now, what do I know? Okay, I know that the angle, I'm going to say angle KML is equal to 90 degrees. This is given. And then I also know that side length KL is congruent to side length KJ, given. I suppose in our example up here, I should have also stated my givens, so I'm going to jump back. Again, you should always start with that. That was bad on Mr. Larson, so I would add in here, I would say AB is congruent to BD, that's given, and AC is congruent to DC, given. So I apologize, I should have done that. Now I have one side, two sides, three sides for side. And if you remember our properties, if we have parallel sides that meet at a 90-degree angle, then we can confirm that let me see here, what was I? And then we have one of those shared sides as well. So again, we always like to look for those shared sides. So I'm going to say that KM is congruent, segment KM is congruent to segment KM. That is the reflexive property. And this is going to be the one example where angle side does work, okay, because of the hypotenuse leg theorem. So I guess we should state that this angle is also 90 degrees. And again, that's just the definition of a right angle, because if it intersects at a right angle on the right side, it has to intersect at a right angle on the left side. So I'm going to say the measure of angle KMJ is equal to 90 degrees. That is Let's just call it the definition of a right angle. And so now I can prove my triangle KMJ is congruent to triangle KML because of the hypotenuse leg theorem. And then I can finish by saying JM is congruent to LM by CPCTC. Corresponding parts of congruent triangles are congruent. Prove LM is congruent to LQ. Okay, so I'm trying to say this section right here is congruent to this section right here. So what we're going to do, we're going to start with what we're given. So I'm going to start by saying side length MN is congruent to side length PQ. And then I'm going to say that angle MN, you could say L or Q, is going to be congruent. MNQ is going to be congruent to angle MPQ. That's also given. And I could also say that this angle right here is congruent to this angle right here because of vertical angles. So I'm going to say the measure of angle MLN is congruent to the measure of the angle QLP by the vertical angle theorem. VAT, vertical angle theorem. And now I have one angle, two angles, and then the next side is a side. So now I can prove it using angle, angle, side. Angle, angle, side is one of our congruence methods. So let's say triangle MNL is congruent to triangle QPL by angle, angle, side. Therefore, LM is congruent to LQ because of CPCTC. You have to use one of our, we have 5 methods to prove triangles are congruent. You have to prove they're congruent before you can use CPCTC. All right, and this last example, a little tricky, but we can definitely do it. So if we start with our givens, my statements, and my reasons, segment ST is congruent to segment TQ. ST and TQ. Angle TSR is congruent to angle TQP. That's marked on there as well. Now what I'm trying to do is get these two angles to be congruent. Now I have quite a bit of like different triangles that I can make up or that I can create inside this shape. So what I'm going to start by doing is I'm going to look at this triangle right here and this triangle right here. And when I do that, I notice that I have a set of vertical angles. So we have some vertical angles right here that are going to be congruent. So I'm going to say that angle STR is congruent to angle QTP by the vertical angle theorem. And now I can say that those triangles are congruent because I have an angle, a side, and an angle. So I'm going to say triangle STR is congruent to triangle QTR by the angle, side, angle property. And because that's true, so I'm going to kind of erase some stuff. So because I proved that those triangles were congruent, this triangle, and this triangle, all parts of those triangles are congruent. So now I'm going to say that this part of the triangle is congruent to this part over here. So we can say that PT is congruent to RT due to CPCTC. Now I'm going to switch triangles because my whole goal is to get angle 1 and angle 2. Now I'm going to look at triangle PTS and triangle QRT. And what do I see that I have again in this example? I see vertical angles one more time right here. So I'm going to say, all right, I also have angle PTS is congruent to angle RTQ by the vertical angles theorem. And if I look here, I have a side that's congruent, I have an angle, and then I have another side. So I can say that triangle PTS is congruent to triangle RTQ by the side angle side theorem. And now, because I stated that my triangles are congruent, all parts of congruent triangles are congruent. Therefore, angle 1 is congruent. Well, I guess we should even say, hey, angle P, well, let's say angle SPT is congruent to angle 1. That's just substitution. I'm substituting those, just saying it differently. And then angle, let's see here, QRT is congruent to angle 2, substitution. Therefore, we can now say that angle 1 is congruent to angle 2, and we've done enough. So what we had to do is we had to prove the orange triangles were congruent, use CPCTC, to then prove the purple triangles were congruent in order to get angle 1 and angle 2 to be proven congruent. So you can see it can be quite challenging, but you have to break it up into steps, prove what you can, and work from there.